If you invested $1,000 in bonds and it doubles every 15 years, write an equation for this to find your variables. So now, here's just a quick review on this. Let's let A of t equals the amount bonds are worth, and then t equals number of years. So we have A of t equals 1,000 times, well, what's happening here? First it was $1,000 is our starting, and it's doubling. That's a multiplication factor of 2. And how long does it take to double? It takes 15 years. So when I plug in 15, I want an exponent of 1. When I plug in 30, I want an exponent of 2, so it'll double twice. What is that? T over 15. What would the interest rate be for this? And what we need to do basically is transfer it to this form, and there's multiple ways that you can go about doing this. One of them is just to look at it to say something like this. 1,000 times 2 to the t over 15 is going to equal a sub 0, 1 plus r to the t. Well, this is telling us that 1,000 equals a sub 0, and you already know that. Now, how do I deal with this rest of the part here? So t to the 2 to the t over 15, that can be rewritten because we want it as 1 plus r to the t. So what number is, how could I write this whole expression to a power of t? It would be 2 to the 1 over 15 raised to the t. So in other words, we have 2 to the 1 over 15 equals 1 plus r. Now note, on here, this r is the rate as a decimal. Now I've already shown before that I dealt with it as r over 100, which is how you convert your rate or your percentage into a decimal. So what we need to do right now is just do this calculation. If you take out your calculator, do it just to make sure that you are doing it correctly. It's 2 exponent parenthesis 1 over 15. You get 1.04729 blah 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 equals 1 plus r. I'll come over here. So in other words, r equals 0.04729, etc. Now, if I tell you that I want you to round the rate to the nearest tenths, what we don't look at this form. We have to first find the rate. Now, this is as a decimal, so what is that percentage? What we would do is multiply this thing by 100, so it is 4.729%. Now I'm going to round it to the first decimal place, so 4.7%. Accurately graph 2 to the x and 1/2 to the x. So what we want to do here is look at a table of values, plug in numbers like -1, 0, 1, 2. -1, 2 to the -1/2 is the same as what? Sorry, I was thinking ahead there. 2 to the -1 is the same as 1/2. 2 to the 0 is 1, 2 to the 1 is 2, and 2 to the 2 is 4. So we can plot those points. We have 0, 1, -1's 1/2, 1 is 2, 2 is 4. 3 would be all the way up here, somewhere in that vicinity. This thing is looking like that. Now, if you were to type this in on your calculator, the calculator is going to make it look like it touches the x-axis. Does it? No way. You do not want to show that this thing touches the x-axis at all. Come in close to your x-axis, put an arrow on. It has a horizontal asymptote there, and that's it. 1/2 to the x. Let's do the exact same thing. Now, when we plug in -1 here, we have 1/2 to the -1, which is 2. and plug in 0, we still get 1, and 1 we get 1/2 to the 1. Which way should I continue on this way? Should I go positive or negative? If I go positive, they're going to keep on getting smaller and smaller, and 1/4 is going to be a hard number to graph. And if I go negative, that'll be 1/2 to the -2, which would be the same as 2 to the +2, which is 4. So let's plot those points. And let me get out a different color here. So -2 gives me 4. And then -1 gives me 2. And 0 is the same. And 1's 1/2. And then -3 would be up there at 8 again. What do you notice about these graphs as we're graphing them? Does anything stand out to you about them? What you should notice is that they are a reflection of each other. And what you want to do is recognize that what is that a reflection about the y-axis. What did we study back in chapter 4 that goes over this idea? How do you reflect a graph about the y-axis? What you're doing is all the positive x values become negative and negative x values become positive. So what we're looking at is f of -x. Well, let's take a look. If f of x equals 2 to the x, f of -x equals 2 to the -x, which is the same as 1/2 to the +x. And so these two graphs are reflections about the y-axis. Here's a little more review from chapter 4. And these are transformations, translations, as well as scale changes. So let's take a look at this thing. If we have y equals 3 to the x, what does y equal 3 to the x minus 1 do to the graph? So if we think of this as f of x here, this is y equals f of x minus 1. What you want to do is recognize it in both forms, but sometimes this helps to jar the memory. What this does is it moves the graph 1 unit in which direction? Right. So y equals 3 to the x is going to look similar to y equals 2 to the x. It's going to look like there. So if we're going to take that graph and shift it over, so now at 1 it'll be 1. The graph is just shifted over 1 unit. What does this one do to the graph? In terms of f of x, this would be negative of f of x. So it takes all of our values that were positive for y values and makes them negative, and if there were negative values, it will make them positive. In this case, we have no negative values for the original graph. It is a reflection about the x-axis, and so the graph looks like, and that value there is 1. Should mark that one. Again, we're not going to touch the x-axis. We're just going to show that it's going to get close to it. And the last one, we have in terms of f, this would be y equals f of -x. What does this do? Oh, I didn't actually say it on here. This is a reflection. It reflects y equals f of x about the x-axis. And this one reflects y equals f of x about the y-axis. And so that graph will look like there, where that value is 1. So there's a little review about what we did in chapter 4, and we're going to have to know that material, and we're going to come back to it and use it throughout the year. The rule of 72. If something grows at a rate R% per year, or month, or whatever it was, then the time it takes to double is approximately 72 over R years or months. We're not going to prove this right now. We will do it soon. If I'm earning 2% in a bank account, about how long will it take to double my money? Well, this is telling us we're just going to take here 72 and we divide it by 2, and that would be 36 years. Which 2% right in today's economy would be pretty darn good. If I'm earning 6% in a bank account, how long would it take to double my money? 72 divided by 6, and that gives us 12 years. Financial advisors will use this thing all the time because it just gives you a rough idea on how long it takes. Why do they use 72? Because 72 has a lot of factors. 8 goes into it, 9 goes into it, which means that 3 and 2 and 4, and then 6. So that since so many different numbers go into it, it's a quick one to do and you can get a nice round number. What if we were talking about 5? Oftentimes what people will use is 70, but we could still stay with 72. It'll just say it's about 14.4 years if we were doing that one. And that's it.